In this video, I'm going to talk a little bit about the molecular basis for blood types, which is a great example of heritable variability in humans. Blood types have to do with the fact that your red blood cells are literally sugar-coated. They contain glycoproteins in their cell membranes. And remember, glycoproteins are proteins that have a sugar attached. And these particular glycoproteins are embedded in the cell membranes of your red blood cells with the sugars sticking out. So again, causing your red blood cells to be covered in carbohydrates. So we can't see it in this picture of red blood cells. So instead we're going to look at this diagram here of the different types of ABO blood type glycoproteins. Again, you can see that the protein part is embedded in the cell membrane. And then there's a carbohydrate chain that sticks out on the outside of the cell. These different types of glycoproteins differ by the carbohydrate chain that's attached to the protein. You can see that type A glycoproteins have this sugar here that's indicated in red. And type B glycoproteins have a different type of sugar there at the very end that's indicated at blue. And finally, the type O glycoproteins don't have that final sugar at all. The gene that determines what type of blood you have, A, B, etc., is located on chromosome 9. And here's the catch. That gene does not code for this protein here. So I'd like you to think about this. What could this gene code for? If you're still thinking about this, go ahead and pause the video so you have time to think. What this gene codes for is an enzyme that modifies the carbohydrate that's attached to the ABO blood type glycoprotein. There's one version of this enzyme that attaches this sugar that makes it a type A glycoprotein. There's another version that attaches a slightly different sugar at the end. And finally, there's a version that doesn't attach any sugar in that place, which leads to it being a type O glycoprotein. A person's ABO blood type phenotype, or trait, depends on the alleles that they have for this ABO blood type gene. In other words, it's going to determine whether they have type A blood, type B blood, type AB blood, or type O blood. You've probably heard about these. This enzyme doesn't modify every single ABO glycoprotein made in a cell, which has this consequence, that people with type A blood or type B blood both have some O glycoproteins on their blood cells, whether or not they have the O allele for the gene, meaning whether or not they have the allele that codes for an enzyme that doesn't attach that final sugar. In your first problem set, you're going to practice applying the principles of inheritance and probability using these ABO blood types and the alleles that code for the different types of enzymes as an example.